Another short video just demonstrating the final configuration of the digital frequency meter attached to the B29 receiver. I modified the takeoff point down here. After experimenting with a few capacitors, I found that something around between 2 and 3 picofarad provided adequate power to the digital frequency meter. It actually provides something in the order of a couple of volts peak to peak, which is more than adequate to drive the frequency meter. So rather than put a 2 or 3 picofarad silver mica capacitor in there, because it's very tight space, I used a little gimmick capacitor made from a couple of pieces of thin wire twisted together, put in the capacitance meter, and then just kept trimming it until I got about 2.5 picofarads. Then I sheathed that in heat shrink and coupled it to some sub-miniature coax, which you can just see down there, a little thin black wire. So it threads from the tuning gang around the back here and goes through the chassis through that grommet. And I removed one of the phone sockets. There's two in parallel. I removed one of those, and it's now tucked under the chassis and insulated, so it's still there and could easily be replaced. And in its place I put a BNC socket, so a digital frequency meter can be plugged into there. The receiver's on, the digital frequency meter's on, and this old BK Precision one, which probably dates from the early 80s or something. There's one digit missing on the latch segment, but it works pretty well with this. So at the moment we're on band 3, and the lower end of band 3 is just under 90 kilohertz, and I've got the signal generator tuned to 88.8 kilohertz, and you can probably hear the beat frequency signal there. The tone can be varied with the heterodyne vernier. As you tune through that signal, and you can see the digital frequency meter going up the scale. So mid scale should be around about 140 or thereabouts. So that should be around about there, which is about half mesh of the tuning gang, which is about right. And at the full unmeshed position, the highest frequency on this range should be around about 220 kilohertz. And we've got 223.6 kilohertz, so that's pretty good. Top end of band 4 should be around about 560 kilohertz, and we're actually reading 550.7. So that could be slight detuning of the capacitor at the high end due to the little loading that the 2.5 picofarads gimmick capacitor is causing it. Top end of band 2 should be around about 90 kilohertz, and we're getting 88.7. So again, maybe some slight detuning there. The top end of band 1 should be around about 38 kilohertz. We're getting 39. So, we're kilohertz out, but the BFO can be adjusted through about 3 kilohertz. So we're in the right ballpark. So I'm pretty happy with that. And it's certainly, the receiver is certainly usable. It's very stable. So if you definitely want to, say for example, you want to tune to 500 kilohertz, you just take it slowly when you get to near 500 kilohertz. You don't need the analog scale anymore. And there you go. So it's within a kilohertz of 500 kilohertz. It's probably more accurate than the actual analog scale. So I think the receiver is perfectly usable without the analog scale working. And I'll probably do a little realignment on that, try and get the scales a little bit just pull it in where it's being pulled by the loading of the small capacitance on the VFO. And I think we're probably about there with this receiver. I checked a few resistors and all seem to be within tolerance, so I don't know if I'll be changing any of those out, but it's on soak test for a few hours, and I'll retest the resistors because they can change after a few hours use, after being unused for decades probably. Okay, that's the B29 with the digital frequency readout.